So when we find the area of composite shapes, we're going to need to keep that in mind, just like we saw in that homework problem, okay? So split the composite shape into smaller shapes. That's true. You can do it that way. There is another way to do it, and that is to really look at it as one giant. In this case, we're looking at rectangles, okay? But most students prefer to split these shapes up into smaller, I don't know that it's more manageable, but smaller shapes. So here we go, looking at this one, and yeah, we saw in the homework, you'll see maybe 2 or 3 like it. But the strategy for solving these is pretty much the same throughout. So if I said, hey, we're going to split this up, this means that I'm going to either cut it here to make 2 rectangles, or I would cut it horizontally to make these 2 rectangles, okay? All right, then it's settled. Let's chop this up vertically. Chop up sounds kind of morbid, but also satisfying. So on this one, we're going to make the vertical cut right here, okay? Which means I'm going to just, I am trying to trace that line. I feel like I didn't do too bad of a job on that one. But in any case, let's go ahead and take this rectangle. Well, we got 2 rectangles, actually, right? We got that red one, and then you see how it creates this other purple one right here, okay? Now, what I'm going to do is I'm going to separate these. Composite just means that it's like 2 shapes pushed together. Like this one's 2 rectangles put together. So I chopped it up right here, and that makes the red rectangle, but it also makes this purple one right here. And so hopefully at this point I can separate these if it'll let me. So I can take the purple one and set it over here, and I can take the red one and set it aside. See, so now I'm really looking at 2 different rectangles, and once I find the area of the red one, I can take the area of the purple one and just add those 2 areas together. But I just need to know what their areas are. Well, what are the dimensions of these, right? We're saying, what is the length and width of these? That's how we're going to figure out the area. So I'd say, okay, I see over here the top of that shape, that's 2 yards. And then this length right here is 11. So there's 11 right there. On the purple shape, I get 3 right here. That's good. That's fine. But the problem is I don't have this side length of the purple shape, right? So I've got to figure that out. And here's how we do that, is I take the 2 yards up here, and then I just move it down here because it's related to that 7 yards. We've seen this before, right? So I'd say, look, that whole side length is 7. We used up the 2 in red, and then that's how much the purple is. 7 minus 2 is 5. So that gives us this length at 5 yards right there. So now I know the dimensions of the purple shape and the red shape. And I can find those 2 areas. So the area of the red there is 2 times 11, length times width, which is 22. Again, that would be 22 square yards, by the way. But I'm not going to worry about the label until we get to the final answer on this one. And the area of the purple shape, length times width, 5 times 3, which is 15. I feel like I didn't mention this, but math nerds everywhere, if you said that the length is the shorter of the 2 sides, they would freak out. So, like, if you ever just want to, like, freak out a math person, just say, hey, look at this length. It's the shorter of the 2 sides, and they will. I try not to. Maybe sometimes it gets to me. I don't know. But let's add these 2 lengths together, right? We got 22 and 15. Add them together. And this will tell us the area of the full shape. So 2 plus 5 is 7 in the ones place value. 2 plus 1 is 3. So it looks like our total final area here is 37. But it's not just good. It's not good enough to say 37 because we need a label for this one, right? This one is in area, which means it's square units, square yards specifically. 37 square yards. Bam, we did it. So let's look at this a different way, as promised. I said I'd show 2 different ways. Now remember, if that first way makes sense to you, just ignore this, okay? Like if you're like, man, I really like that, I understood it, I don't need a second way. Pretty much, I'm asking you to like get up away from your computer and just take a break, okay? But if that last way was confusing, then this way may make a little bit more sense to you. Am I guaranteeing it will? No, I am not. But I hope that it will, all right? So what I'm going to do first off is to say, let's look at this thing as though it were just a big rectangle, one big rectangle. So I have these two long sides. I'm just going to just kind of make a full rectangle out of this, like so. And I can move this over, right? Now I have a rectangle, and I can find the area of this rectangle, right? It's an 11 by 7 rectangle. So to find the area of this one, it's just length times width. 11 times 7 in this case, which is 77. And yeah, I know it's in square yards, but I'm not too worried about that. Now, you may be thinking, hey, this is bigger than the answer we got from that last part that we did. That's true. That's because I included all of it, whereas, in fact, what we have here in red, like this, is not actually included, all right? All right, I'll say that that's decent right there. There's the red one. So, again, just combining these. So if I look at this red one, and I, just kind of compared it to the purple one, see how it fits in there? And then what do we get? We get the actual shape we're trying to find the area of in here. So whatever I have in red, since it doesn't actually exist as part of the area we're solving for, I just need to subtract it from the area of the purple. Okay, so I take the 77, I subtract whatever this area is on this red one. But I don't know what the dimensions of that red one are, so I need to figure them out. Now, just like we saw in the first method, which we're going to have to use the same method here, I got 7 yards here. At the top, I got 2 yards, which is 2 of the 7, which means the rest of it is 5 right here, okay? Which means that right now it's a 5 by something rectangle. And I'm going to use pretty much the same strategy to solve the other length. So I'd say this 11 right there. And this is 3 here. So the 3 would take up this part. And to solve for the red there, I take the 11 yards and subtract the 3 off the side. And that would tell me the other dimension. 11 minus 3 is 8. So the red rectangle here is 8 by 5. And again, I need to find the area of this rectangle here, which is 8 times 5. That's 40 square yards. So to solve for the total area of the original shape, I would take the area of the purple and the area of the red. Purple is 77 square yards. Red is 40 square yards. And all I'm going to do is subtract these. So 7 minus 0 is 7. 7 minus 4 is 3. And you see we get the same exact answer. 37 square, almost put feet on that, yards. Same answer, different method. And again, hopefully that worked out for you if that first method didn't make sense. Sometimes it does. There's not so many students that use this method, but every once in a while it will click better for some students than others. I definitely am not saying that you have to use one or the other. And you don't have to use the one that's the most popular. So choose which one you like and roll with it.